Okay, so it's in class 12 continued. So we finished question 1 and 2, so let's do question 3. So it says 1,200 people were surveyed and 380 thought that climate change was not caused by human pollution. Find the 92% confidence interval for the population mean and the margin of error. So let's go back up to our top here, and we have our z-test steps and our confidence intervals. Okay, so let's go down to the bottom and find the confidence interval. So here it is. Just take this and then we'll paste this at our bottom of our question. So let's go down to question 3. Okay, so let's paste it here. Okay, so it involves finding x bar. So let's find x bar. And also we need to find sigma and n. So note here, note n is equal to 380. Oh, sorry, 1200. And okay, so let's find our x bar. So our x bar then is going to be 380 out of 1200. So let's compute it here. So in our case, our x bar is what we're calling p hat, sample proportion. So it's 380 out of 1200. Okay, so that you worked it out as 0.3167. So we figured out the x bar guy here. Now let's find the sigma. So let's do that next. So note in the question we were not given the population standard deviation. But when you have proportions like this, we can find the sigma this way. Let me write down here. So since we do not know the population standard deviation, we use it's roughly equal to the square root of p hat minus times 1 minus p hat. So our p hat guy was our x bar, so it's 0.3167, so it's going to go here, then 1 minus 0.3167, square root of this guy. You can check it's 0.465. That's what we're going to use for the sigma there. So we know the sigma, we know the n. So we need to find the z alpha over 2 now. Let's find that next. Okay, let's first find the alpha value. So so this guy up here is a 1 minus alpha confidence interval. So right here. So in our case, we want it to be 92%. So that's going to equal our 1 minus alpha. Let's put it down here. So note 90% confidence interval implies the 0.92 then will equal the 1 minus alpha. So if you solve for alpha then, it's basically saying 1 minus some number is equal to 0.92. So think of the one like $1. So $1 take away how much is 92 cents. So it'd be 8 cents. So it'd be 0.08 as our alpha. Now we in the formula up here for the confidence interval, we need to find alpha over 2. So we need to divide this guy by 2. So let's do that. Okay, so dividing it by 2 is going to be 0.04. Let me just write out here. So dividing this guy by 2 would be 0.08 divided by 2, so it'd be 0.04. So now we need to find this guy here. Okay, in our case, we found the alpha over 2 was 0.04, so let's write that out in our case. Okay, so writing that out. So pretty much just writing this equation here with the z alpha over 2 being 0.04. Let's do that here. So we need to find then and 1 minus 0.04 then would be 0.96, you can check. So we're going to have to use the z-table to try and figure out this guy. So let's look at that. Let me put my z-table here. So here's how we're going to have to look at our z-table. So let me write it here. So using our z-table, we're going to look in the body of the table for a value of 0.96. So let's do that. So let's look at our Z table in the body for 0.96. Let me click on it here. Enlarge it. So we're going to look down now, look in this table for 0.96. We may not be able to find it exactly, but let's find the ones closest to it. So looking here, we got 0.9599. That's pretty close. And the one after it's 0.9608. So one's a bit too small, one's a bit too big. So we're going to take the one that's a bit too big, just to be on the safe side. So going across this way corresponds to 1.7 there, and going up this way corresponds to 0.6, so it looks like it's going to be 1.76. So now let's go and put that in our table. 176. Okay, so going back, so our value is 1.76. Let me write what we found then. So we see that a Z value of 1.76 corresponds to 0.9608. Hence our Z of 0.04 is 1.76. Okay, so we got everything we need now for our confidence interval. Let me just write down here again. So putting it down here, we got everything we need now. May I just actually cut it from here and paste it down below. Okay, let's put it here. So we're going to start to plug into this now. We got all these values. We have the Z.04, 1.76. We have the sigma. We have the X bar. We have the N. So the N is 1200. So let's start plugging in. Okay, so start plugging into this. Let me actually right here. Let's see. Some of this stuff down. Let me get this down. Right here. Right here. Go to another page here. Okay, so plugging into the formula then, our X bar is the 0.3167 that we found that up there. Okay, and then it's going to be, so it's X bar then sigma. The sigma we found is 0.465 right here. The N value is 1200. So it'll be square root of 1200 here, times our Z alpha over 2, which is this guy here, so 1.76. So working that out, you get 0.3403. That's pretty much we're doing this side of it here. Let's keep going. Okay, so also, so doing an X bar minus sigma over square root of N, Z alpha over 2 in our case, would be this. So pretty much we're computing that one we just found was 0.2931, and the first one we found was the 0.3403. So now we can write our confidence interval. Let's write our confidence interval, or 92% confidence interval. So hence we can say with 92% confidence that the population mean is in the interval 2931, that's this guy here, on this side to this one. And let's also find the margin of error. So the margin of error is basically the this guy here. It's the sigma over square root of N times Z alpha over 2. So that's in our case, it's this guy here. Okay, so let's write that. So we can say then, writing that out. So moreover, our margin of error is 0.0236. Okay, so we're done with this question. So let me leave it there.